Negative 2 to the power 4. What is it? Is it positive 16 or negative 16? So today I am beginning pre-calculus lesson 1, which is exponents. So please keep on watching this video. Hello everyone, welcome back to Dona's Academy. So today I am beginning pre-calculus lesson 1, which is exponents. Okay, so first of all, I would like to go over the exponential notation. Exponential notation. All right, so if we have a real number a, so a is a real number and n is a positive integer. Then we use this notation a to the power n. We call it a to the power n, or sometimes a to the n. We just say a to the n. So a to the n. Now, what do we mean by this notation? This means that we multiply a by itself n times. That is the meaning of this notation. A to the power n or a to the n means we are multiplying this number a by itself n times. So here this a is called the base and n is called the exponent or power. Sometimes we say power exponent. All right, so let me take an example. So if we have let's take 5 to the power 3. Here the base is 5 and the exponent is 3. So this means we are multiplying 5 by itself 3 times. So the answer is 125. Alright, so we learned the notation and the meaning of that notation, exponential notation. Now let me introduce the laws. Some laws of exponents. Laws of exponents. The first one is, if we take any base, let's say a, and power 0, then it is always 1. No matter what base you choose, it doesn't matter. It can be positive base or a negative base. It is always, the power 0 is always 1. Second one is, if you have a negative power, a to the power negative n, then this is same as 1 divided by a to the power n. This is kind of a definition, not exactly a law, even though I included it in laws. This is kind of a definition. The third one is, if we are taking two powers of the same base and if we are multiplying these two together, a to the power m times a to the power n, then this is same as a to the power m plus n. So we are adding these two powers Here adding these two powers if we have the same base. Now, ever wondered why? Let's see why. Okay. So why this is true? Okay. So now if I expand a to the power n, a to the power n, what do I get? I get first I have to multiply a by itself m times, and then I have to multiply a by itself n times, and then I am multiplying both of them together. Now how many a's do I see here in total? Here I see 1, 2, 3 up to m. Here I see 1, 2, 3 up to n. So altogether there are m plus n number of a's. Right? So that's why I have a to the power m plus n. Alright, next one. Here the third one was multiplication. Now I am taking the division. A to the power m divided by a to the power n. So here I see again the same base. In this case, this is equal to a to the power m minus n. We have to subtract these two powers if we see the same base. Here I added. Here subtract. So if it is multiplication, you have to add the powers. If it is division, you have to subtract the powers. Now again, let's see why. Here actually we have to consider two cases. The first case I am considering is if m greater than n. Alright, so in that case, a to the power m divided by a to the power n is same as, now I have m number of a's in the top. However, since m is greater than n, now here if I am starting from 1, then since n is less than m, I have nth a, and then starting from n plus 1th a, I have it up to m. And in the bottom I have a, here my first a, here my nth a. Alright, now I can see that I can cancel these n number of a's in the top and the bottom. Then how many a's left in the top? You can see that there are no a's left in the bottom. However, you have some a's in the top. How many a's do we see? We cancelled n number of a's in the top. So we have m minus n. Here I have m minus n number of a's. So that's why this is a to the power m minus n in this case. Alright, so this is one case we considered for m greater than n. Now my second case is if m less than n. In this case, how do we expand this? Now m is smaller, so I have m number of a's starting from 1. This is the mth a, and then here I have n is bigger than m, so I have a up to mth a, and then m plus 1th a, and then nth a. Now I can see m number of a's in the top and the bottom, so I can cancel them. Then how many a's left in the bottom? There are no a's left in the top, it is just 1. How many a's I see in the bottom? I can see that there are n minus m number of a's. So I have this. In that case, I do have 1 divided by a to the power n minus m. However, we know that by the second law, by this law, we can write 1 over a n minus m as a to the power negative n minus m, right? So I can replace this by a to the power negative n minus m. Now if I distribute the power, I get a to the power m minus n. Alright, so that's what I wanted. Alright, so I proved this law for both two cases. Now what if m and n are equal to each other? In that case, we get 1, right? So we get a to the power 0 and we get 1. Alright, this is the fourth law. Now my fifth one is number 5, power of power rule. If we have a to the power m to the power n, then this is same as a to the power m times n. We have to multiply these two powers, not addition, it is multiplication. Now again, let's see why. Why? Alright, so here if I distribute this, what I get is am multiplied by itself n times. So I have n number of a to the power m terms. So if I distribute each of these blocks, if I if I expand each of these blocks, then what do I get? I have m number of a's in each, and I have n number of such blocks. This is my first one, and up to here, this is my nth block. So how many a's do we see in total? It is nothing but m times n, right? So we have a to the power m times n. If this is not clear, let me take an example. So suppose I have a to the power 3 to the power 2. Then what is this? A to the power 3 times a to the power 3. Now if I expand each of these blocks, a times another block of 3 a's, right? So I see two number of 3 blocks. And how many a's do I see in total? 6. That is 3 times 2. So I have to multiply the powers. Or here I have a to the power 3 times 2. So it is a to the power 6. Right? That is what is this is what happening here. All right. The next one is a b to the power n, and this is same as a to the power n, b to the power n. Again, let's quickly see why. I can expand this as I have AB blocks n times. Now, how many A's do we see here? There are n number of A's. And how many B's we see here? Again, n number of B's. Now, since the order doesn't matter for multiplication, we can rewrite or rearrange this as A multiplied by itself n times and then B multiplied by itself n times. Here n, here n. So, I do have A to the power n, B to the power n. This is here. Okay. Next one, number 7. The division. A divided by B to the power n. This is same as A to the power n divided by B to the power n. Again, let's see why. Now, this thing can be expanded as A to the power B times itself, A divided by B. A divided by B multiplied itself n times. Now, this is same as A multiplied by itself n times divided by B multiplied by itself n times. Right? Here I have n. Again I have n. And this is same as A to the power n divided by B to the power n. Now, if you are not sure, let's take an example. So, if I have 3 over 4 times 5 over 7, then this is same as 3 times 5 divided by 4 times 7, right? So, it doesn't matter if we rewrite in this way. So, this is what I did here. So, that's why we have this law. Alright, so I'm done with laws. So, let's recap those. So, what I had was, so first I had A to the power 0, it is 1, and then I had this negative power rule, and then multiplication of the same base powers, addition, division of the same base power, different powers, it is the subtraction, and power of power, so we had to multiply the powers, and then different bases but same power, this is the expansion, and different bases, same power division. Here it is actually, in the previous one it was the multiplication. So these are the 7 laws we have in exponents. Alright, now let's do some examples for each of these laws. And at the end I will explain the question I had at the beginning, which is negative 2 to the power 4 case. Alright, so examples. First one, I take, if I take 3 to the power negative 2, then I can use the negative power rule. This is same as 1 divided by 3 to the power 2, which is 1 over 9. Second one, let's take same base, different powers, multiplication. 2 to the power 3, 2 to the power 2. So this is same as 2 to the power 5. Addition, right? Not the multiplication. We have to add these two powers. So 2 to the power 5 is 32. Third one. I take the same thing, division. So this is same as 2 to the power 3 minus 2, which is 2 to the power 1, which is exactly 2. Fourth one is power of power thing. 2 to the power 3 to the power 4. Now what do we have to do? We have to multiply the powers. So 3 times 4, 2 to the power 12. Right, so since this is a big number, maybe you have to use a calculator. So the answer is this. All right. Number 5, 20 to the power 5. Now, how do we use laws for this calculation? We can write the inside number as 2 times 10 to the power 5. Then we can use the AB to the power n rule. So this is same as 2 to the power 5 times 10 to the power 5. And 2 to the power 5 is 32 and 10 to the power 5. So we have to write 5 number of zeros after 32. Okay. All right. Next one, the division. Different bases, same power. So again, we can expand it like this. 4 over 7, not 7, 49. 49. Last, or not the last example. Now I come to the question I had at the beginning. So what do you think about this? Is it positive 16 or negative 16? Remember that you don't see any parentheses here. So in that case, this power 4, this power is not applying to this negative sign because you don't see any parentheses like this, right? So in this case, this is same as negative and then 2 to the power 4. Alright, so this is same as negative 16. So the answer is negative 16, not positive 16. Okay. Alright, now what if I have this? Negative 2 parentheses to the power 4. Then this power 4 is applying to negative 1 negative sign also. So in this case, this is same as negative 1 times 2 to the power 4. Now we can use the rules, the AB to the power n rule. In this case, this is same as negative 1 to the power 4 times 2 to the power 4. Now what is negative 1 to the power 4? Remember that any even power of negative 1 is always positive 1. So in this case, this is positive 60. Positive 60. So if you see parentheses like this, then it is positive. But in this case, in the previous case, it is negative. So you have to be very careful if you are multiplying, if you are taking exponents of a negative number. Be careful with the parentheses. I mean even power, right? Next one. How about odd powers? So if I have this thing, now this is same as negative 2 to the power 3. This is negative 8. How about if I use parentheses? Now this is same as negative 1 times 2 to the power 3. So this is same as negative 1 to the power 3 times 2 to the power 3. Now what is negative 1 to the power 3? 3 is an odd power. So any odd power of negative 1 is negative 1. So this is negative 8. So you can see that it doesn't matter if you have parentheses or not for odd powers of negative numbers. It is giving the same answer. Negative answers always. So you don't have to worry about if you are taking an odd power of a negative number. However, you have to be very careful when it comes to even powers. Be careful with the parentheses. Now, what if you have my last example? What if you have negative 2, 0? Now remember that 0 is considered even. So in this case, this is same as negative and then 2 to the power 0, which is negative 1. What if you have parentheses? In this case, this is same as negative 1 times 2 to the power 0. This is same as negative 1 to the power 0 times 2 to the power 0. Now what is negative 1 to the power 0? He said that any 0 power of any number, doesn't matter positive or negative, then it is 1. So this is 1 times 2 to the power 0 is again 1, so positive 1. So again, we get two different values depending on the parentheses, right? So again, we have to be careful whether we have parentheses or not when it comes to power 0. So power 0 is considered even. So if it is even power for a negative number, you have to be careful with the parentheses. All right, so I think I explained the section exponents with the laws and some examples, and very important examples like powers of or exponents of negative numbers. All right, so thank you so much for watching. So I will upload the other lessons too soon. So I hope you enjoyed the video. So as I always say, please subscribe to the channel if you haven't done already, and please press the bell icon next to it. And if you enjoyed, please like the video and share it with your friends. All right, so have a nice day and stay tuned.